So, ladies and gentlemen, let's do some long division. Before we do it with polynomials, we're going to do it with just numbers. So let's go through and remind ourselves how this works. We're going to divide 6,372 by 11. Okay, if you wrote it out like 6372 divided by 11, we're using a fraction bar. This is how we write that using long division. So we've got a two-digit number here. What we're going to try and do is figure out how many times 11 will go into 63. So you think, okay, well, 5 times 11 is 55. So 5 times 11 is 55, and you put the 55 underneath the 63. And then we're trying to figure out how far away it is from 63, so we subtract. And 63 minus 55 is 8, and then we pretty much do the same thing again. Since 11 is not going to go into 8, we'll drop down to 7, and now we say, okay, 11 times what? 7. That'd be 77. Okay? We're, again, trying to figure out how far away 77 is from 87, so that's 10. 11 doesn't go into 10, so we drop down to 2. 11 times 9 is 99, and then 102 minus 99 is 3. And since 11 doesn't go into 3 and we don't have any other stuff to bring down, that's our remainder, so we say remainder 3. So 579, remainder 3. That means that I can multiply 579 times 11, and I will be 3 short of 6,372. So if I write my answer, and we're going to use this notation for polynomials as well, as the quotient times the divisor plus the remainder. The quotient is what you get at the end, 579. The divisor is what you're dividing 11 into, the dividend. So quotient times the divisor, which is 11, plus the remainder, plus 3. If you do the quotient times the divisor plus the remainder, you will get the dividend, 6,372. And that's how you check your answer. If you type this in, you'll get 6,372. So I know I get it right. What we're going to do now is basically the same thing, but with variables. So we're doing with polynomials. So we've got our dividend here, which we need to write in standard form, y squared plus 5y plus 4. And we're going to divide y plus 2. So y plus 2 is our divisor. And this is pretty much the same game, only it's with variables. So you'd figure out, okay, what can I multiply y by to get y squared? Well, if I multiply y times y, I will get a y squared. But you have to multiply y times the entire divisor. So y plus 2 gives you y squared plus 2y. So if you want to say, okay, part of the quotient is going to be y, you have to make sure you distribute y into this. So now it's y squared plus 2y. And the trick to this is, when you subtract, we're going to subtract, but you can't just put a minus sign here because you're subtracting a quantity. This also has to be subtracted. So now it's going to be y squared minus y squared. Those cancel out. That's what we're basically trying to repeat. But 5y minus 2y is 3y, so I have 3y plus 4. Now I do the same thing. Y times what will get you 3y? So you say, okay, multiply by 3. That's 3y, but again, you have to distribute because you're multiplying the 3 times y plus 2. So it's 3y plus 6. 3y plus 6. You have to distribute the 3 into y plus 2. Now you flip the signs, so those are now going to be opposites. Those cancel out. 4 minus 6 is negative 2. And since y is a higher degree, y plus 2 is a higher degree than what we're working with here, then we are done. That's our remainder, so our remainder is negative 2. Now we're going to check this the same way we did the other one, but we're going to actually multiply it out. So quotient times divisor plus remainder. So the quotient is y plus 3, y plus 3. The divisor is y plus 2, and the remainder is negative 2. So if I FOIL this out, y times y is y squared plus 2y plus 3y plus 6 minus 2, y squared plus 5y, and 6 minus 2 makes 4. Y squared plus 5y plus 4. Hey, look, that's the dividend. So I know we did it right. You're going to write your answer as quotient times divisor plus remainder, and then you actually expand it out, and you kind of verify your answer. So let's try another one. We're going to have our dividend, which we need to put in standard form, and you'll notice how there is a missing degree here. We have an m squared, but we don't have an m to the first. So when this happens, your best strategy here is to put like a placeholder in there. It's 0m, but it's going to make it easier to line things up. Long division has a lot of stuff that has to be in the right place. So it's the most useful thing you can do is anytime you're missing a term, put a 0 in there as a placeholder. It'll just make it a lot nicer. You'll see what I mean in a second. So we've got our dividend, and our divisor is 2m minus 1. And now I'm going to start to play this cancel union. So 2m times what gives you 4m squared? That would be 2m. 2m times 2m is 4m squared. So 4m squared, and remember you need to distribute. 2m times negative 1 is negative 2m. But we are subtracting this, so this becomes a minus and that becomes a plus, so that those cancel. And now we have 0 plus 2m, which is 2m plus 13. Now we do it again. 2m divided by 2m, or 2m times what gives you 2m? That would be plus 1. So distribute a 1, 2m minus 1. And now I'm going to again subtract. So now this is minus and this is plus. Those go away. 13 plus 1 is 14. Since 14 is degree 0 and our divisor is degree 1, this is a lower degree, we're done. So then that's our remainder. Remainder 14. So if I write my answer as quotient times divisor plus remainder, the quotient is 2m plus 1. The divisor is 2m minus 1. And then my remainder is plus 14. Now I'm going to just say, like, that's my answer, but I'm still going to check it. So I'm going to FOIL this out. 2m times 2m is 4m squared minus 2m plus 2m minus 1 plus 14. So those cancel out. 4m squared and 14 minus 1 is 13. Did I do it right? Yep, that's the dividend, so I know I did it right. That's how we're going to write our answer. Quotient times divisor plus remainder for every problem that we do with division. Let's try another one. This one says use the factor theorem to show that x minus c is a factor. So you got to think about what that means. If I say, like, let's say 5 is a factor of 30. What does that mean? Like, how do you know that 5 is a factor, or how could you tell? Well, generally what we'll do is we'll say, like, okay, what's 30 divided by 5? And you're like, 6. You're like, is it a factor? Yes, it's a factor because there's nothing left over. Or another way of saying that is the remainder is 0. If you divide and you get no remainder, then that means the number that you divided by is a factor. So what we're going to do is we're going to divide to see if it's a factor. But the trick is, if c is a 0, then x minus c is the factor, so x minus 2. If you tell me that 2 is a 0, then that means that x minus 2 is a factor. Just like before when we had a factor, like say x plus 4, if that's a factor, then x equals negative 4 is a 0. So if you give me the 0, 2, then that means x minus 2 is a factor. If this is a 0, then 2 is a factor. So what I'm going to divide by is x minus 2. So my divisor is x minus 2, and my dividend is still, let's see, do we have any missing degrees? 3, 2, 1. No, we don't need any placeholders. X cubed plus 2x squared minus 3x minus 10. We're testing to see if x minus 2 is a factor, because if it is, then c is a 0. And I'm going to give you this in sort of two different formats. I might give you a 0 to test, or I might give you a factor to test. But either way, you're doing the same thing. We're going to go ahead and start dividing. So x times what gives you x cubed? That would be x squared. Now you need to distribute, so it's x cubed minus 2x squared. And then you got to be real careful here. You got to flip the signs. Minus plus, so those go away. And we do it again. 2x squared plus 2x squared is 4. Oops. Is 4x squared minus 3x. And now we play the same game. X times what gives you 4x squared? That would be 4x. So I distribute a 4x. Now I have 4x squared minus 8x. Make sure you flip your signs. So now it's minus plus. 8 minus 3 is 5x. Oops, doing the same thing. 5x minus 10. Now I do the same thing one more time because these are both degree 1. So x times what gives you 5x? That would be 5. Distributed 5. 5x minus 10. 5x minus 10. Uh-oh. This looks good. Minus plus. Those cancel out and those cancel out, so it's 0. That means that the remainder is 0. If the remainder is 0, that means that you have a factor. So we'll check it, and maybe this will help you kind of see it. If you have the quotient times the divisor, x minus 2, and then you say plus remainder, well, plus 0, I'll write it, but you don't really need to write it. Now when I expand out, you're like, wait, that's a factored form. Look, there's no remainder. This is a factored form. We have this times x minus 2. If I expand it and get the dividend, then I just use long division to help me factor something that I might not have been able to factor before. So let me factor or FOIL it out. X squared times x is x cubed minus 2x squared plus 4x squared minus 8x plus 5x minus 10. Combine my terms. 4 minus 2 is 2x squared, and negative 8 plus 5 is negative 3x. X cubed plus 2x squared. Look, it's right there. It's the dividend. So what we did was we were given a 0, and then we used that 0 to factor a polynomial, which we've never been able to factor this. This isn't factorable by grouping. So we're learning a new strategy here. If you give me a 0, I can use division to then take a cubic, knock it down to a quadratic using that factor that I have. So this is a pretty powerful tool that we're using. But by checking my answer, I know that I have the right quotient, which is the main goal. It is a factor because the remainder is 0, and there's the factored form. So we're going to do a few problems here. My suggestion would be for you to pause after each problem, then watch me do it. That way you're actually getting the practice. If you just sit here and watch me do it, you've already done that. You guys need to try these at this point. So that's what you should do, is pause it, work it out, then watch me do it, and then repeat that. So I'm going to go ahead and go through this. I have x minus 4, and I'm going to use my dividend as x squared minus 6x minus 8. So I'll go a little quicker here on the back. X times x is x squared. X times x is x squared. Distribute x squared minus 4x. Flip your signs. Minus plus 6. Negative 6 plus 4 is negative 2x. And then x times what gives you negative 2x? That'd be negative 2. Distribute a negative 2. Negative 2x plus 8. Flip your signs. Plus, minus. Notice these are not going to cancel out, even though it's real tempting. When you flip the sign, you're going to have negative 16, and that's your remainder. So it's x minus 2, remainder negative 16. Now, I'm going to write my answer, and I think it's important that you check it, but I'm just going to write it out as quotient x minus 2 times divisor plus remainder, and that is my answer. But again, you should always practice checking it. X squared minus 4x minus 2x plus 8 minus 16. That's negative 6x. And then 8 minus 16 is negative 8. X squared minus 6x minus 8. Awesome. I did it right. Another one. Okay, so 3x plus 6 is my divisor. My dividend is x cubed plus 3x squared plus 4x plus 3. And now we start to go through here. But this one's going to be a little trickier because x times x squared gives you x cubed, but 3 times what gives you 1? You actually need to divide by 3. So I'm going to say, write that as 1/3. Or you could write it as x cubed over 3. Because if you multiply, or x squared rather, x squared over 3. Because if you multiply x squared over 3 times 3x, you get 3x cubed over 3, which is just x cubed. So I have to distribute that, and that's going to be x squared over 3 times 3x. That's what I just did right here. That's your x cubed. And then I also have to multiply times 6. So plus 6 divided by 3 is 2, and 2 times x squared is 2x squared. So a little bit of fraction multiplication there. Minus, minus, those go away. 3 minus 2 is 1x squared. That's not squared. X squared. Bring down your 4x, and then do it again. So 3x times what gives you x squared? That would be x, let me do that in blue. That would be x over 3. Because 3x times x is 3x squared divided by 3 is 1x squared. So when you distribute, you get x squared plus x over 3 times 6 over 1 is 6x over 3, which is 2x. So this is plus 2x. Now I'm going to flip my signs. Those go away. 4 minus 2 is 2x. And then one more time, I can do this one more time. 3 times what gives you 2? That would be 2/3, and I don't need an x because it already has the x. They're both degree 1. Because 2/3 of 3. If you multiply 3x times 2/3, you get 6x over 3, which is 2x. And that's what we're trying to get is 2x. So this would be 2x, and then 2/3 of 6. 6 times 2 is 12. 12 divided by 3 is 4. And then when you flip your signs, minus, minus, you get negative 1 as your remainder. So the remainder is negative 1. So this one's a little trickier to check, but again, you need to be real good at this, and fractions shouldn't be the end of your world. We're going to have the quotient, so x squared over 3 plus x over 3 plus 2/3 times the divisor, 3x plus 6, remainder negative 1. So let's expand this out. If you do this times 3x, that would be 3x cubed divided by 3, that's x cubed, plus this times 6. 6x squared divided by 3 is 2x squared. X over 3 times 3x. 3x squared divided by 3 is just x squared. Let me get that out of there. It's x squared. X over 3 times 6. 6x divided by 3 is 2x. 2/3 times 3x. 6x divided by 3 is again 2x. 6 times 2/3, 12. Wait, did I miss one? 2/3. Oh, no, I'm good. 2/3 times 6 is 12 divided by 3, which is plus 4, and then minus 1. So I should have 6 multiplications. 1, 2, 3, 4, 5, 6. And then x cubed plus 3x squared plus 4x, and 4 minus 3, or 4 minus 1 is 3. So x cubed plus 3. Hey, we did it. All right. So you have fractions in there, but that is your answer. Again, that's something you should be able to handle. Multiplying fractions is essentially, I just divided by 3 a couple times. If you can't divide by 3, you might be in trouble. Let's see, we got one more like this. Now, this one's going to be a little weird because it looks like, it might not matter if it's in the divisor. 3x squared minus 7x. We don't have any placeholders to worry about. That's what I was going to say. Dividend, 9x squared minus x plus 5. So now I'm going to go ahead and play the same game. 3 times 3 is 9, and x squared, wait a minute, this is just 3? Yeah, those are the same power, so okay, we'll distribute a 3. Now I have 9x squared minus 21x, and when I flip my signs, minus plus, those go away. Negative 21x minus 1x is 20x plus 5. Now, this, our divisor, is degree 2. And what we're trying to divide here is degree 1, which means that's actually the remainder. You're not going to divide an x. You wouldn't multiply by 1 over x. So this is our remainder, 20x plus 5. Remainder, 20x plus 5. And again, that's because this is degree 1, and our divisor is degree 2. So if what you're trying to multiply into is lower degree, then you are finished. That is your remainder. So our quotient is 3. Quotient is 3 times the divisor is 3x squared minus 7x, and your remainder is plus 20x plus 5. This is the quotient times the divisor plus the remainder. So now we'll distribute 9x squared minus 21x, and then we have plus 20x plus 5 on the end, which is 9x squared minus x plus 5. Hey, we did it right. Okay, so this is your answer. One more, we're going to use the factor theorem to show that this is a factor. Or another way of saying that is that c equals 1, that c is a 0. So if c is a 0, which is 1, if 1 is a 0, then x minus 1 is a factor. We're used to going the other way. Normally I'll tell you a factor and then you tell me the 0. Well, here I'm giving you the 0, you have to give me the factor. So that means we're testing to see if x minus 1 will get a remainder of 0. That means it divides evenly, so it's a factor. But this is one where your dividend is going to have some placeholders because we have 0x squared and we have 0x's. If you don't do that, then stuff doesn't line up very well. So now we'll say x times what is x cubed? X squared. Distribute an x squared, x cubed minus x squared, and then we say minus plus, those go away. X squared plus 0x. Do it again. X times what is x squared? X, distribute an x squared minus x plus 0 plus 1x is 1x, x minus 1. And then x times what gives you x? That would be 1. Distribute a 1, 1x minus 1. Oh, look, same thing. So when I flip my signs, those both go away and you get 0, so the remainder is 0. Now I'm going to write it as quotient times divisor. We'll check it. We will be done. So quotient is x squared plus x plus 1. Divisor, x minus 1. So we just factored. Because the remainder is 0 plus 0. You don't really need to write plus 0 on the end because plus 0 is the same as the additive identity. Now we're going to distribute x cubed minus x squared plus x squared. So x cubed minus x squared plus x squared minus x plus x minus 1. Cancel, 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 cancel. X cubed minus 1. Hey, look at that. X cubed minus 1. Aren't those both perfect cubes? Oh, this is a difference of cubes. And look, there's the factored form. So if you just would have straight factored it, you'd be like, yeah, it's a factor. X minus 1. So we used long division to essentially derive a difference of cubes factor. That's kind of cool. So you do have a math lab for this. Make sure you go ahead and take care of that. And also, while you're at it, why don't you hit that like and subscribe button?